Hello, so in this video we're going to continue with the Stretchy IK system. So thus far we've got Stretchy working on our IK leg. Z to undo. And as we stretch the leg, there's one thing that we need to keep in mind. So as the scale increases in X, what we need to do is account for the volume of the leg. So if this leg is stretching, in order to retain its volume, as it stretches in X, it's going to have to shrink in Y and Z. Okay, so what we're going to do with this node is find the inverse value of that stretch and apply it to these joints. Okay, so let's just set it back to where it was. And so what we're going to need to do here is I'm going to take let's zoom in a little bit. Okay, so we got the X scale from the output here on the thigh, and I'm going to take that value and I'm going to put it here into input 2, and then I'm going to come to this Stretchy inverse multiply divide node, attribute editor. And what I'm going to do is just set that to 1. Okay. And what we're going to do here is divide it. So this value that's being piped in is the scale value. Right now we're at 1. And as this scale increases, we want to divide 1 by that scale. So for instance, let's go ahead and stretch it a little bit. Come back here. So as this scales, we're going to divide 1 by that to get the inverse. So let's undo this. So in order to get the inverse, we're going to take the output here. And that's going to be from the X, because we're just using the X here. And so for the thigh, so we're going to take this output X, and the inverse scale is going to be, for Y, is going to be that. Same thing for Z. Plugging this back into that node. And we'll do the same thing over here. So the inverse scale for Y's going to be from there. Same thing for Z. And so now let's go ahead and scale this. Come back to this. So we're scaled at about 1.5. And the inverse scale on the Y and the Z is the inverse of that number. So the whole idea here is that any geometry that's bound to the skeleton, as it stretches this way, it's also going to shrink in so that it retains its volume and it looks natural. And we'll demonstrate that just as soon as we constrain the bind skeleton to the IK. So I'm going to go to the bind skeleton. I'm going to add the thigh and the knee. What I'll do is just sort of stagger those. Pop those open. Okay, so what we'll do now is we'll make the bind scale visible. And let's take the scale from the phi IK, the X scale, and let's plug that into the scale for the thigh. We can also plug it into the scale of the knee. So let's just test this. Okay, great. So the bind skeleton is scaling. It's scaling with the IK, but it's not actually rigged up to follow it. So we did that in another video. And I'll just have you guys combine all of that. Okay, so that was pretty simple. Now we can take this inverse scale and we'll plug that into the Y and the Z for both of these. And now what I'll do is turn on some leg geometry that I've got there, just so you can see how this works. So let's take the IK, and now the thigh joint's visible. So let's scale this. So what we can see is that if we scale it, it's going to retain its volume. So as it stretches, it's just going to get a little thinner. So that's what that inverse scale nonsense is about. And, mathematically, that may be off a little bit, but it's close enough. Okay, so that is hooking up a stretchy limb, and this would work for arms, legs, if you wanted to, anything that you wanted to stretch, add stretch to. That's how you go about doing it, or at least one way. Have fun.